When you're solving trig equations, there's two important points to start with. One is the arguments need to be the same, theta and theta. All right, that's good. The other is, whenever possible, get everything to be the same trig function. So get everything to be cosine or everything to be sine. What I'm going to do is I'm going to replace the cosine squared. So cosine squared is equal to 1 minus sine squared. So we would have 2 times 1 minus sine squared, and then minus sine of theta, and then it equals 1. Now go ahead and distribute this 2. So there would be 2 minus 2 sine squared minus sine equals 1. Now we need to put everything on one side of the equation, get everything together. Also, whenever possible, I like the sine squared one to be positive. So I'm going to move it over to the right side. So the left side will have 0. So add this to the right side, it becomes a positive 2 sine squared. Also add the sine to the right side, it becomes positive sine of theta. And then subtract 2 from both sides, and 1 minus 2 will be negative 1. So this one is quadratic. We may need to use the quadratic formula, or it's possible that it could factor. So I'm just going to get scratch paper and see, could it factor? So you would have to have 2 times sine of theta, and then we would have to have sine of theta. That way when you multiply these two, that's going to be the 2 sine squared. In order to get a 1, it would have to be a 1 times a 1. And in order to get a negative, I would need a negative and a positive. And then let's see if it worked. So when you multiply these, that's negative sine of theta. And when you multiply these, that's going to be positive 2 sine theta. And that leaves behind a positive sine theta, which is exactly what that is. So it does work. I can factor it. Now I'll just transfer that to my actual answer. So it factors as 2 sine of theta minus 1, and then sine of theta plus 1. If the factoring would not have worked, then I could always use the quadratic formula. Factoring works sometimes. When it does work, it's faster, but it doesn't always work. And if factoring doesn't work, the quadratic formula always works. So now that it's factored, you set each factor equal to 0 and basically separate it into 2 separate problems now. Set that one equal to 0. Set this one equal to 0. So for this one, I could add 1 to both sides and then divide by this 2. So it's saying, when does sine equal a half? This one, subtract 1 from both sides. It's saying, when does sine equal negative 1? Well, this one I could answer by just looking at the graph of sine. The directions said to use radians. So this would be 2 pi. This would be pi. Here's negative 1. And so it equals negative 1 right here, which is at 3 pi over 2. So there is one answer. Then what about this one? When does sine equal a half? So perhaps you have the unit circle memorized. I don't. So I can use the calculator. Make sure that it's in radians. and then take sine inverse of a half. So it gives me this decimal 0.524, and I'm pretty sure this is pi over something. To figure out what it is, you divide by pi, and if you're going to do this, don't type the decimal, just hit divided by pi, and then go to math and convert that to a fraction. So that means it's 1/6 of pi, or in other words, pi over 6. Now, if you look at the graph of sine, and then when does it equal a half? If you draw a line straight across, there's actually two solutions. One solution is the one that we just got, pi over 6. And then there would be another solution right here. Well, right here where it crosses the x-axis, that's pi. This one is just to the left of pi. And because the graph is symmetric, if this is a gap of pi over 6, then this is also a gap of pi over 6. So this solution is actually to the left of pi by pi over 6. So subtract. And if you have 1 of something and you subtract a sixth, so 1 minus a sixth is 5/6, so it's going to be 5 pi over 6. Now, I need to check the answer, because there are times when you do algebra and it produces extra answers that aren't actually a solution to the problem. So I definitely have to check the answer. So I'll go and graph the original problem, which said 2 cosine, on the calculator I need to use x instead of theta, get squared minus sine of x. And then it said, when is that equal to 1? Now, change the window. Got some ink on my calculator. Change the window to go from 0 to 2 pi. And for the y values, it's got 2 times cosine, so that could, let's go with -2 to 2. That should be good enough to see it. So the two graphs cross one time right there, a second time, so it's got 2 answers. There's the third time, and that's it. So we should have 3 answers. Now I'm going to test these. So go to trace and put pi divided by 6. Yes, that one is correct. And then 5 pi divided by 6. Yes, that one's correct. And then finally this one, 3 pi divided by 2. All 3 are correct. So 100%, 100%, 100%. Nailed it.